Assalamualaikum and hi. Welcome back. Let's continue with example number 8. Figure shows reinforced concrete retaining wall which support a cohesionless soil having the following properties. As in figure, there's a retaining wall and the retained material here is soil. Unit weight of soil is 19.8 kilonewton per meter cube. This one is unit weight of soil. Angle of shearing resistance is 30 degrees. This one is theta. Unit weight of concrete is 24.5, which is unit weight of wall. Check the stability of the wall satisfying the following design criteria. Means that you have to check to make sure that the factor of safety against overturning more than 2.5. Factor of safety against sliding should be more than 2, and maximum base pressure should not exceed 100 kilonewton per meter square. If you get the value not satisfying this, meaning that the retaining wall will not be in a stable condition. First, as usual, we're going to calculate for RV, RH, stabilizing moment, and overturning moment. How actually we're going to divide the retaining wall so it is easier for us to calculate the area and the moment. We need to identify the A and B first. The side which retain material should be B. Here I divided this one area as W1 and another one it is as W2. And here we also have a retained soil that sit on the top of the retaining wall, which we have learned in step retaining wall. If the soil sit on the top of the retaining wall, it means that the weight of the soil will help to stabilize the retaining wall. Therefore, we have another one, WS1, which is weight of soil 1. First, we will do for the first weight 1, okay, W1, which is the height of W1 is 7.5 and the width is 0.5. Therefore, for W1, it is 0.5 times 7.5, the area, and times with the unit weight of the wall, as according to the question, this value. And we need to look at the lever arm from A, means that the centroid of the W1 should be here and it go down, right? So this one, this force will become a moment, okay? And it must be 90 degrees from the force ataupun from the weight. Okay, if you look at here, it is 90 degrees, meaning that we need to find this distance, L1. Therefore, 0.5 divide with 2, and then you have to plus with 1.1 meter. And you will get 1.35. And times the force with the lever arm, you will get 124.031. And we will do for W2. For W2, the width is 3.6 and the height is 1 meter. And the lever arm should be from the centroid, which is at the red dot here. It should be half of 3.6. Means that 3.6 times 1 meter times the unit weight of the wall, and you will get the force. For the lever arm, it should be half of 3.6 to go to A, and you will get the moment here. And for WS1, let's not forget, we have another weight that help to stabilize the retaining wall, which is weight of the soil. For this one, we need to look at the area. The area will be 2 meter width, right? And the height should be 7.1, okay? Because of the soil is up until here only, therefore 7.5 minus 0.4. And let's not forget that here you need to times with the unit weight of the soil because you are calculating the weight of the soil. And the soil unit weight is 19.8 kilonewton per meter cube. How about the level arm from A? Look at here again. And for this one, WS1, the red dot there shows that, okay, half of 2 meter plus with 1.6 meter. That is the distance to get to A. That will be 2.6. And the moment about A is 731.016. And we need to total up the vertical forces and the stabilizing moment. Next, we're going to calculate for RH. So RH here, we're going to look at the lateral forces ataupun lateral thrust atau lateral pressure. So anything yang horizontal, arah dia should be inside here. In this case, there's only one force, which is the soil itself. So soil ni yang cause the retaining wall untuk overturn. Now we look at here, that will be the pressure distribution for the soil, which is for the soil, it should be at this point, the value will be Ka, unit weight of soil, times H. Or Ka, density of soil, times G, times H. So if we want to calculate the total pressure for this PA, since this is the active lateral thrust daripada the soil, the formula would be setengah, okay, sebab kita kira area dia setengah Ka, unit weight of soil, H darab dengan H. It will become half Ka, unit weight of soil, H square. Or if you use the density, okay, it become half times Ka times density of the soil times G times H and times H. Right? The height. So height apa? Height of the soil meaning that dari sini sampai bawah ni. At the very bottom of the retaining wall up until it reach the top of the soil. Then it become half Ka density of the soil GH square. This if you use the density instead to calculate for the pressure. But usually I will use this formula. It depends on if the question give you density or unit weight. First PA, right? And then we use the formula again. So this is half times Ka times unit weight of soil. Since soalan ni bagi unit weight of soil times H power of 2. Samalah dengan apa yang saya tulis tadi. Okay, so Ka, kita kena cari Ka ni. Right? Sebab ini adalah soil, so should be dia ada value Ka. So Ka will be 1 minus sin theta. Mana saya dapat dari formula ini. Right? So pakai formula ini to get the value of Ka. Theta here should be 30 degrees since the angle of shearing resistance given in the question, it is 30 degrees. You can use 1/3 or you can also use 0.333. Unit weight of soil 19.8 and you times with H power of 2 which is the height of the soil. Meaning daripada bawah ni lah. Okay, nak sampai ke atas, paling atas soil itu. Okay, so 7.1 from here to here, it is 7.1. And you have to add another 1 meter down here. So, jadi 8.1. And you calculate, you get 216.513 for the lateral thrust from the soil. And you will need to find the level arm from A, since the pressure distribution for the soil is also uniformly increased, means that the triangle macam ini, jadi distance dia nak berpusing ke A like this, it should be 90 darjah. So maksudnya bancang inilah yang you cari. So itu adalah 1/3 daripada the height of the soil, which is 8.1. I get 2.7 for that, and times the lever arm with the force, you get 584.585, and that will be our total overturning moment. After this, we need to calculate for the position of ground reaction using this formula again as example number 7, right? We need to find the value of x. The B, which is for our question here, is this 3.6 ya. The width ini adalah 3.6 meter the base length. The base length, and then minuskan dengan stabilizing moment, which is according to our answer here, it is 1013.807 minuskan dengan 584.585 the overturning moment, and bahagi dengan 461.235 the vertical force. Here I get 2.669 meter from B. So we need to use the middle third rule again for this question. So you have a retaining wall like this. This is 3.6, and you have to divide it to 3. Okay, so the soil is at the back here, which means this is A and this is B. So 0 will start at B. So divide by 3. So 1.2, 2.4, and 3.6. And since you get the value of X, or position of ground reaction, 2.669, it means that this is outside middle third. Okay, sebab kalau inside, it should be within this, dalam ni, tengah-tengah itu, antara 1.2 ke 2.4, tapi sebab dia keluar, dia lebih daripada 2.4, therefore it is outside daripada B. And we can write here, so base ni adalah 3.6 meter wide, therefore middle third antara 1.2 to 2.4. And the position of ground reaction ataupun RV, resultant force here, cuts outside the middle third. This will not exactly produce adverse consequences in reinforced concrete. Okay, walaupun there is tension in the joints, but tak semestinya it will produce consequences yang sangat teruk lah. Mungkin konkrit tu akan rosak sebagainya. Tak semestinya Kita dah dapat this one, but this question tak minta pun kita untuk check the tension in the joints, but it just that dia minta kita untuk cari the ground bearing pressure sebab dia bagi some values for us to compare. Right, so because of this is outside middle third, okay, not as example number 7. Example number 7 dia inside middle third. This one dia outside middle third, therefore kita akan pakai formula ini. Okay, so I nak senang I pakai this formula You can also use this formula, no problem. However, you need to calculate the value of E, which is eccentricity. So lebih senang you ambil je value formula yang ini, because semua value-nya you ada dah. QA equal to 2V divided with 3B minus X. So V here is the RV lah, which is the vertical forces. Okay, just ambil je value ini. that is the RV. 3 dalam kurungan 3.6 is the baseline minus with the value of X yang inilah. And you will get 330.279, okay, which this value is bigger than 100 kilonewton per meter square. And QB also adalah 0. Walaupun QB adalah less than 100 kilonewton per meter square, but supposedly retaining wall tu hujung ke hujung dia adalah A and B kan. Mungkin dia selamat dekat B tapi dekat A dia tak selamat. So doesn't matter, it will still fail lah. The whole retaining wall must be safe lah. Tak kisahlah dekat point A atau point B kan. Right, so here QA nya fail And mana saya tengok 100 ni daripada the question 100 kilonewton per meter square. It says that it should not exceed. Tapi kita dapat 300 plus, meaning it exceed already, so it is not safe Next, we're going to check for overturning and sliding. For that, FOV, which is factor of safety against overturning, we have the formula of total stabilizing moment bagian total overturning moment. And you pun tahu, we just use this value that we have in the table here for stabilizing moment and overturning moment. This one dan yang ini bahagikan saja, you will get the answer. 1.734 and this is less than 2.5. As you can see, the factor of safety against overturning must be more than 2.5, but we get the value less than 2.5, meaning that it is not safe. And for sliding, okay, we can check, okay, sebab sliding we know that mungkin dia bagi mu, mungkin dia bagi delta. But in this question, dia tak ada bagi mu, dia tak ada bagi delta. It's just that dia bagi angle of shearing resistance 30 degrees. Angle of shearing resistance bukan untuk kira, tak sama dengan delta Ini adalah theta. So kita sebenarnya nakkan the delta, which is angle of wall friction. But since soalan ni tak ada, tak bagi, therefore we can assume that the angle of wall friction delta is equal to angle of shearing resistance. This is our assumption only. Using the formula of factor of safety against sliding, we need to find the value of mu. Mu equal to tangent delta, and kita dah assume delta adalah sama dengan theta. So delta adalah sama dengan 30 darjah. You get 0.577 and masukkan saja dalam formula. So RV here is the total vertical forces that you can refer from the table. And P here adalah equal to RH, horizontal forces. You can also refer from the table, these two. And you get 1.229 for the answer, which is, it is less than 2 because for sliding, the value should be more than 2.0. However, according to your answer here, the value is 1.229, which is less than 2, meaning it is not safe. That will be all for this example. See you next time. Bye guys.